holiday season and 2026 as well. So, what's on our agenda for today is we have, of course, our usual welcome all of you. We have a few holiday NUG breakers, and then we're also going to get some exciting updates from Dr. Debbie Bard on American Science Cloud as well. And then we'll go over a few general nurse updates as well. Cool. So, a little light holiday nug breakers, and feel free to share either in the chat or by or in or coming on and speaking or on camera. So a good little question. If you had unlimited node hours, what problem would you solve? Debbie, you look like you're thinking.
I am thinking.
What type of simulation might you want run, or what problem would you want to solve?
I would hand out the note hours as like a completion award for doing like our surveys. Because we have so many times when we're like, oh, we really wish more people would do these surveys. And we'd like to hand out more note hours as like the carrot. So
You know, you took
this
that in
would
a
be great. We'd be able to hand out so many.
yeah, you took that in a completely different direction, and I love it. Yeah.
Yeah.
What about you, Debbie? Did you have any thoughts or ideas?
My mind immediately went back to the running well, I in my before I came to NERSC, I worked in cosmology and running. I used to run a lot of cosmology. Actually, it's part of my work at NERSC as well. But running cosmology simulations, but with using AI models that is surrogates in the simulation. That's what I'd if I had unlimited hours, I'd love to play around with that.
Okay, cool. I know for me, I would want to probably explore more on understanding simulating particles and particle physics. So I'd have to rope Lippy in to help me with that. But that's meant I've been reading like a lot of research in that area lately. So that's one area that has my attention now. All right, another little breaker we have. What software tools or programming languages are you looking to learn in 2026? Vibe coding is a real big thing right now and makes things easier. So that's something I've been leaning into more and learning more about already. Anyone else?
I want to see if Julia lives up to the hype.
We'll see. Yeah. You're gonna try it? Try
That's
using Julia,
that's
or do
my
you?
hope. Yep. And I'll learn it enough to be able to try it convincingly.
Okay, cool, cool. Yeah, we have a lot of staff members that are um Julia and evangelists as well. So all right. Well, with that, we'll go ahead and get started. We have here today with our for our first presentation, Dr. Debbie Bard, and she's going to give us some updates on the American Science Cloud. And Debbie is our director for the Department of Workflows and User Engagement here at NERSC. And so we are glad to have her here with us. And you should be able to share your screen, Debbie.
Yeah. Okay. Okay. All right. Thanks for the introduction, Charles. I have I think 15 or so slides, and so I'm going to be happy to take questions as I go along if people have anything, or if you want to ask questions at the end. I didn't prepare an enormous amount of material because I wanted there to be time for conversation. I know this is something that a lot of people have a lot of questions about. So I wear a lot of hats at the moment. As Charles said, I'm a department head here at NERSC. I'm also the chair of the leadership group for the Integrated Research Infrastructure Program, which is a kind of an evolution of our super facility work here at NERSC. And that's a DOE program designed to connect the OSCAR facilities and beyond. I'm also a product manager or lead product manager now for the American Science Cloud. And it's kind of with that hat on mainly that I'll be talking here about what the American Science Cloud is and kind of an update on some of our plans, what we're doing at the moment. So American Science Cloud is part of the Genesis mission. And if you haven't seen the sort of announcements around the Genesis mission, I suggest you Google it. There's a lot of information out there. There's from the Genesis mission website. There's a few videos and some really good background information. But this is a mission that's come out of DOE that is really ambitious, and it's really designed to support scientific computing broadly. The kind of products that are being developed from the Genesis mission is an integrated platform that connects the DOE's facilities and DOE resources, but also connects data sets across all the scientific domains in the DOE. And there is a specific goal to double the productivity and impact of American research within a decade. It's not entirely clear how that's going to be measured, but that is what we're aiming towards. And honestly, we're hoping we will be able to demonstrate an impact by the end of this year that is working towards this goal. It's worth noting that the Genesis mission encompasses multiple offices within DOE. So we're working in the Office of Science here at NERSC, but this is also a close collaboration with the NNSA and with the Applied Energy Labs, and it's really a whole of DOE efforts to develop this platform as part of the Genesis mission that will enable not just AI to be better integrated into our workflows, but to help all scientific workflows just run more efficiently, more effectively. Taking away some of the pain points, or I'll talk about this in a bit, but some of the specific pain points that can happen when you're trying to operate across facilities. So what is this looking like in practice? So we're really leveraging the DOE's infrastructure for this to enable transformational models within the Genesis mission. And there are currently, this is not a limited list, this is currently the three kind of areas where funding has been appropriated and allocated for work within the Office of Science. So this came out through the American Science Cloud item on the One Big Beautiful Bill, appropriations bill last year. And this is covering three areas. Developing AI models with both within DOE, but also in partnership with industry leaders. This is through the Consortium for Transformational Models, or ModCon, as it's known colloquially. There's also significant effort within DOE to assemble fully AI-ready data. This is partly funded through some calls specifically from the Office of Science, but there's also a lot of effort happening within DOE towards this. And then there's the infrastructure platform, devising this set of cloud-like services and interfaces that span computing, network, storage, code. And this is the part of this that is the American Science Cloud. The American Science Cloud is designed to support, through infrastructure, through the appropriate services, the work being done by everyone within DOE working towards the goals of the Genesis mission. So that's kind of the broader context and how American Science Cloud kind of sits within the Genesis mission. It's also worth noting that the Genesis mission is evolving. It's relatively new, and there's new and exciting things kind of coming up all the time. So we can expect to hear a lot more about this in the next and other opportunities in the next couple of months. So let's talk a bit more about the American Science Cloud. It is a platform for transformative science that is combining people and contributions from all the labs listed here. So it's a good chunk of the national labs system is involved in this. It was a project that's funded for 1 year and launched on October 1st. So we're like 2 and a bit months in now. It feels a lot longer than that because we've made so much progress in the last couple of months. But what we're aiming towards is designing this cloud environment that hosts the facilities, the DOE's computing, both computing and experimental facilities and data resources and networks as infrastructure, but provides a set of services and interfaces that allows scientists to do the things they need to do for their scientific computing. So creating and accessing world-class AI-ready data sets, preparing those data sets, running model training, fine-tuning, performing distributed simulations, controlling instruments, and so making that real connection between experimental facilities and computing resources, and of course moving data efficiently across sites to wherever it needs to get to. So let's dive into this a little bit more. How are we planning on doing this? Well, we have a set of teams. Excuse me, I'll show you a very complex architecture diagram in a bit that kind of describes a little bit more detail how this fits together. But we have core teams that where we have staff from across the national labs working together on things like interfaces, different kinds of services, working with our partners to integrate them fully into this infrastructure. And what we're producing in practice, what we're delivering is a set of unified APIs for data model workflow access so that you should be able to run a fully automated API based workflow. And that also, we're also thinking about who uses such an API. There will be humans who are using this API, but there's also going to be agents. And so we're thinking about what it means to provide a composable kind of MCP friendly set of interfaces for agentic workflow construction. Something that is coming up, it's been coming up for years when we're talking about, excuse me, when we're talking about integrating DOE resources is the virtual organization model. How do we provide secure federated identity? How do we ensure that data is available to the people who have access to it and is restricted as appropriate? How do we make it easier for people to get accounts across multiple sites? Can we avoid going through vetting procedures multiple times and cybersecurity training multiple times? Can we have true federated identity so that someone can log in one time and be able to use that account at whatever resources they need to access across the DOE complex? That's something we've been working towards for a long time, and we're able to really push for some changes, the necessary policy, high-level policy changes that are needed to enable this through the American Science Cloud. And of course, all of this is designed to provide this seamless interoperability between the DOE facilities, which we've been working towards again in the integrated research infrastructure, the IRI program, but pulling in now cloud service providers as well, and making it easy for scientists to run their workflows on the resources that they need and the resources they have access to. Okay, our deliverables. This is at a very high level, but we've recently produced a scope document where we have in a lot of detail we've kind of bashed out what exactly are we delivering at each of these stages, but at a very high level, at the 3-month point, excuse me, which is end of December, which is, soon, we already have some fairly ambitious goals for what we're going to deliver, and we're on track to deliver these. In fact, in a little more than what we initially listed here. So this is, we're going to have the first example of unified login across multiple HPC centers, not full federated identity, that's going to take a lot longer time, but we're going to have the first examples of this. We will have stubbed out our API and the Python client to do most of the capabilities that we think we're going to need within the American Science Cloud, which will enable authentication. We'll have some the data set discovery. So we have a data catalog that we'll be building that'll be part of this, and also a model catalog, and also the first kind of look at what it would like to run workflows through this API. So that's something that we're working very hard on, that we will be presenting in early January. And in late January, there'll be a webinar that we will advertise quite widely, I think, where we will be kind of showing off what we've been able to accomplish so far. And it'll be including this, the deliverables from this 3-month period. Our 6 months deliverable is something that is really important for us. This is where we are onboarding our first science teams, where we will be able to execute true end-to-end workflows. So that involves identifying data, moving the data where it needs to be, identifying a model, combining the data and the model to do some model fine-tuning. And that'll be the first demonstration of the AmSC capabilities and the power of the AmSC platform. And then at the 9-month deliverable, we will have the first intelligent workflow milestone. So where we'll have early agentic workflow framework demonstrations and sort of showing what it looks like to have having agents performing these reason-based inference across both DOE and cloud resources. And it's not written here, but at the 12-month point at our project, 1-year project end, we'll be delivering the MVP, the minimum viable product, which is going to have all these capabilities and should be useful and usable by the scientific community. This is all, thinking in the long term. This is really a new way. We've been building towards this for a while in DOE, but this is a new way of doing, of thinking about doing science and doing scientific computing. It really emphasizing this need for integration across the DOE resources and kind of enabling scientists to continue their leadership in AI-driven science. So we're also thinking, we have a short-term kind of set of sprints where we're producing demonstrations and initial products, but we're also thinking carefully about what this means in the long term for how we can support this through the virtual organization model. Okay, so the scope in a nutshell, as I kind of mentioned, there's 3 major problems: simplifying account creation and authentication by common processes across all the labs, improving automation for users and agents via this API, and enabling AI in scientific simulation workflows, which by supporting flexible and composable pipelines for training and inference. These are kind of our high-level goals. It is not everything. There's a lot of other aspects that kind of come up as we're working through this. A lot of small and large problems that we're working on, but those are detailed in the scope document, which we're going to be able to publish soon, I think. Okay, so this is a very complex, detailed chart showing our architecture, and I want to just spend a moment just kind of going through it to sort of orient you so you understand what this is looking at.
Debbie, not to interrupt you, we had a couple of questions in the chat. Do you want to address those now or afterwards?
Yeah, absolutely. Yeah.
Okay,
Okay.
so
I can see the chat, so I can go through these. Okay, so I see the first question. Is it fair to say IRI has been subsumed by American Science Cloud? Not exactly. A lot of the ambitions we have with IRI are being fulfilled by American Science Cloud, but we are still, and you'll see this in this diagram, you'll see in the pale purple here. I'm not sure if you can see my cursor. But the IRI API is foundational to the American Science Cloud. So that's the way that we're thinking about this. The IRI work we did with IRI is the American Science Cloud wouldn't be possible without the foundational work we've done with IRI. And some elements are going to remain within the IRI program, and those elements are primarily the API. And so there's the kind of the interface of the IRI API, which has been developed now for a couple of years by an IRI team. But then there's also the backends to the API, which live at each facility, and that's also being developed under the auspices of the IRI team. So you could think of the IRI, which is something we've always been kind of intending as being kind of the standards body. Although not in such a formal way, but they're developing the schemas, the specifications for the API at the facility level. And then services are being built on top of that. We can certainly make the slides available. And then let's see, Heather's next question. There'll be a call for the 6 months milestone of science team onboarding. There will, but the pool of science teams that will be involved in that, I think, will be somewhat limited to the teams that are part of the American Science Cloud infrastructure partners. So those are people who submitted proposals to the original American Science Cloud call for proposals. And then there was a second group of kind of our users for the 6-month milestone, which are the model teams, seed teams. These are science teams that are part of the ModCon, the Models Consortium, which is another sort of, which is our kind of sister group within the Genesis mission, who is working to develop cutting edge models for science applications. And so some of we're calling them seed teams. They are sort of part of ModCon, but will be our first user base. So there's not going to be a public call for science teams at the 6-month point. Okay. Okay. Anyone else have questions while I'm here? Okay. So let me talk through this a little bit. So at the top here we have the interfaces level. So there's we'll have a portal, we have an API portal, we'll have a dashboard and a website where users kind of come into this. And that we're going to be supporting multiple ways basically of interacting with AmSC. It can, but perhaps people just want to use a web interface. People might want to have SSH tunnel into the systems to do what they usually do. And we'll also have API access. And this API will call services from a number of different work areas. We have data services, a data catalog, data movement. We have at-scale services, which are designed to support all the things we do at scale on a supercomputer, inference, simulation, and particularly important curated software stacks that will be common across the facilities involved in this. We have model services, everything around running models, training models, tracking model development. And then we have another box here, another work area around intelligent interfaces. And again, intelligent interfaces are going to be a little slower to ramp up, but at the 9 to 12 month point, we'll be having more capabilities available for agentic workflow specifically. So all of these will interact via the IRI API with a resource catalog, resource orchestration layer, and underneath this, services will be farmed out to the various sort of infrastructure partners, resource providers that are part of American Science Cloud. And so this might be NERSC, it might be one of the leadership computing facilities, maybe there's specific requests that go to ESNet, there might be requests that go to run on cloud service providers, perhaps people have time on AWS and will run there, perhaps people are using resources at Slack, at PPPL, at Fermilab, perhaps they're using resources at the Applied Energy Labs. Those are all going to be plugged in through this resource orchestration layer into the services, the catalog of services. And then there's a very important part that I want to mention, which is the virtual organization. And honestly, we are aware that this is the hardest thing to do because it's not technical, it's policy driven. We've always known this, and this is the group that is orchestrating the things like authentication across the sites, federated ID I just talked about, but really importantly, access controls. And how do we make sure that people have access to the models and data that they are permitted to access and no more than that. So this is kind of the current thinking about the architecture. And I want to give one example of what a user might do with this. So if you're coming in as a user, what does this look like? Well, you come into the dashboards, to the portal, and you say, well, I've got data at my experiment facility, and I want to move it to one of the facilities listed down here. Maybe it needs to come to NERSC. Maybe it needs to go to OCI. Maybe it needs to go to SLAC. And so you register that data with a data catalog and arrange the data movements through the data movement services, which might be Globus, it might be a different data movement capability. There's a number that we'll be supporting. You also have a model that you wish to use. This might be a frontier model, it might be one you've developed yourself, but you register that model with the model catalog here, all again through API calls. And then you train the model on the experiment data using the fine-tuning or workflows as a service capabilities, and that will happen, at the site that you've specified. And then you report the results back to the science team, to your people. That will come back up through the stack of services to the dashboards and through the American Science Cloud portal. And so, we expect this might be something that people do interactively, and making sure that all the necessary authentication access controls are applied, but eventually this could all be automated, and you could eventually have an agent doing this kind of as part of your experiment workflow. Okay, so what does success look like? We've got a few different definitions of this. The technical success is obvious. We want to build this ecosystem. It's got to work. And it's got to be useful for science. So we want to build this secure, interoperable, multi-site integrated cloud. We have specific milestones for that, but also we have success in terms of programmatic success, really truly integrating what's happening across the DOE, across the Office of Science, and across NNSA and across the Applied Energy Labs. So when we talk about programmatic success, we're talking about from the perspective of DOE programs, like what does it look like for us to be successful? It's been very clear that we need to be working together on the Genesis mission. And then, of course, there's strategic success and having a national impact. So across the Office of Science, supporting science problems, but DOE-wide and perhaps beyond, demonstrating the skills and the capabilities we have within DOE, showing our leadership in this space. Okay, I'm just going to take a moment now to talk about how this sort of is relevant for NERSC specifically. We've been thinking about this a lot in the last couple of months. So we have a lot of NERSC staff who are working in these various aspects of the American Science Cloud. We've got people working in data services and at-scale services, in the infrastructure. We have a lot of experience in this space through our work with the super facility model, through our work with the integrated research infrastructure. So we are able to sort of bring that expertise to bear on these some of these work areas. But we've also thought about this a lot in terms of our next system, DAUDNA, the NERSC 10 system. And this is a slide, that we've been showing for a long time, talking about how our thinking behind DAUDNA, and how do I put this? We're prescient in recognizing the impact that AI workflows will have on system design. So we're actually really excited for the arrival of DAUDNA. We are going to have to make basically no changes to the system architecture and the software design to account for American Science Cloud, because we were already thinking along these lines when we designed the system a couple of years ago. So all these aspects of combining AI training and inference with simulation and modeling and experiment data analysis, kind of having these connections to other sites and other systems, having connections to cloud, and all the services that we're designing for the way people interact with DAUDNA. We already have this encapsulated in the system design, so we're really excited to see how DAUDNA performs when it arrives. For American Science Cloud workflows. So things like having the appropriate level of hardware diversity, including CPUs, GPUs. The workflow environment knows it'll host a lot of the services that are needed to support these kinds of workflows. We have our quality of service storage, which is going to be really useful for some of the IO intensive AI applications. And we've already been thinking having APIs for all user functionality was already front and center in our user software environment story. And so those are going to be really useful to plug in to the American Science Cloud platform as that gets developed. We're already thinking about Kubernetes services on platform data streaming, and we have the services that we're already planning around training, fine-tuning, and inference. So really the message here is that Doudna is going to be ready for American Science Cloud with only relatively small tweaks to what we're originally planning. So we're able to leverage a lot of the work that we're already doing with Doudna to support American Science Cloud, which is fantastic. This is a reminder of the advanced workflow capabilities for Doudna, which is part of our KPPs, by the way. Our key, how we define project success is by delivering these capabilities. And so many of these resource orchestration, the seamless end-to-end high-performance AI workflows, the self-service shareable and customizable environments, the portability aspect, container as a service platform, cloud native workflows, all these IRI multi-facility workflows, kind of all of these capabilities have elements of American Science Cloud in them. And so what we're thinking about is how do we tweak perhaps some of the, rather than redesign or rethink, but tweak some of these, the use cases we're going to be using for these capabilities to enable American Science Cloud workflows to be operational on Doudna from day one. Okay, and that's basically what I just said. We're already supporting a lot of the services already, which is exciting for us. We've seen the way that scientific workflows have been heading for a while, and so we're really excited for the Genesis mission platform and to be part of it and to be supporting it. And I think that's everything I wanted to say.
Thank you so much, Debbie, for the update. And we did have two more questions in the chat.
Okay, let me have a look. Okay, is there any point on the American Science Cloud about more intelligent resource usage and allocation? I think that is an excellent question. That is something that we've been talking about. So as part of the, let me go back to the architecture diagram just so I can point to it. I didn't mention this, but we have so there's a couple different aspects. We have intelligent operations, which initially is going to be simply monitoring and logging what's happening, but we do have a plan to develop this further and sort of go into this more intelligent resource usage and be able to allocate resources kind of across the participating facilities in a way that's a little bit smarter, kind of using AI ML to do this. Allocations, specifically sort of allocations as in time is allocated to users, is in flux at the moment. We're still using the traditional methods of allocations for the foreseeable future, where people are we've got a pool of time that is set aside for American Science Cloud applications, and time is being kind of doled out through that. But we also recognize, and this was a point that we were really pushing with the IRI program as well, we recognize that people need reliable multi-year allocations across multiple facilities. And this is the framework by which we're going to be able to develop that. We have initial plans for that already. I hope that answered your question, Jessica. Let me know if there's... Okay, thank you. Okay, so from Heather, an AI playground. Exploring AI tools, also having access to data at NERSC. I think that's a really good idea. It's a good training opportunity. We haven't talked about something like this specifically, like kind of an AI playground, but I'll pass that on to our AI services team. This might be something a really sort of fun way to do this. We do a lot of training around AI, but those are specifically training events, you know, where we have kind of hackathons. We invite people to come and learn about specific tools. But having something that's self-service might be really interesting. I think that's a really, really good idea. So I'll pass that on.
Do we have any other questions from anyone else? In the meantime, I feel one question I do kind of have for you is,
Yeah.
what do you feel is going to be one of the bigger bottlenecks in getting all of the integrated services connected, like working with,
It's going to be authentication and access control, auth n, auth c. That's just, we know this, we always knew this. It's not going to be the technicalities of it, it's going to be the policies and the the changes to policies that need to come into place to allow, and it's going to be really uncomfortable, because facilities don't set these policies themselves generally. These come through a completely different office, the Office of Operations within DOE. And that comes through kind of the lab security officers. This isn't something necessarily the facilities have control over. And so this is why the Genesis mission, being a whole of DOE effort, is really important for making changes and enabling. For example, if I have a particular lab or facility might be uncomfortable accepting a user to run on their system if that user has been authenticated elsewhere. You know, is their identity has been authenticated at another site, they have to trust that site that they're doing a good job at authenticating, and then allowing that person to come and run on your systems. If they do something bad, then it is that facility that is responsible, not the original authenticating person. So having that, it's not simply saying, I trust you, it's having the processes in place and the assurances in place and the risk ownership in place in the right area for everyone to be comfortable saying, all right, we've got these users coming in through the American Science Cloud, they're authenticated elsewhere. It says the token that comes along with them says that they have access to these models and that data. All right, we can let them do the thing that they want to do on our system. That's the part that's going to be challenging. And we know what needs to happen to make it happen. It's just the number of conversations that have to happen at DOE headquarters to get that moving. That's going to take some time.
okay, yeah, that was a very insightful response, and I figured it would be something along those lines because it's always basically coordinating efforts and getting everyone access to
Absolutely.
different resources.
Absolutely.
Awesome.
Yeah.
Awesome. And Lippy and I and our lead Rebecca, we're also a part of the American Science Cloud team working with Debbie as well. So we thought this would be a very good talk for all of our users to hear about. Did we have any other questions? No. Okay, cool. Well, thank you so much on the updates, Debbie. And we'll probably, in a couple more quarters, maybe invite you back to give us some more updates and thoughts and perspective.
Yeah, I'd be very happy to. Thank you. I appreciate the opportunity to tell people about this. It's a fast-moving area, and I know it can be hard to keep track of everything that's happening, but that was our best knowledge of what's happening right now.
Yeah, it is overwhelming with all of the advances that are really happening so quickly. So, good times to be a scientist.
Absolutely.
All right. Well, we will just go ahead and continue on with just a few of our announcements. So one thing is yesterday we opened nominations for the NERSC Early Career Awards. This award is intended to recognize early career researchers who are using NERSC resources to help advance science through computational work. And so the award is open for nominations. Nominations close on January 30th, 2026. It is eligible for anyone that's degree was received after January 1, 2019. And we have two different categories that we typically go for our science awards. The High Impact Scientific Achievement Award is used to recognize someone that has done an exceptional work that is very impactful and helps improve scientific understanding, engineering design, and broad societal problem impact. And then we have the Innovative Use of High Performance Computing Award, which is essentially someone maybe applying a new methodology or approach that has a large impact on high performance computing. And so it could be something like investing or researching more into user workflows or something along that nature. So we encourage all of our users, if you're working with someone and you want to nominate them, or you can self-nominate as well, you can do so. And additional details on how to access the nomination form are available in our weekly email as well. And a few more little updates that we have. We have a few calls for participation. So we have our quantum information science at Perlmutter call for proposals that are open and seeking for proposals. We have the computational science graduate fellowship application that is open and closes on January 15th. And then we also have our Oscar Leadership Computing call for proposals that are now open as well. When it comes to next training events, currently right now, we're still finalizing our 2026 training event calendar, but we do have our new user training and Perlmutter best practices training occurring in February. This is an event that will allow for you to gain access to our new Canvas learning management system, get a digital credential for once you've completed the training, and of course, learn more about all of the new updated best practices on Perlmutter. So we encourage not just new users, but users that maybe need a refresher on best practices to attend. And registration is required, and it is a virtual training, and you can register via the email, via the link in the weekly email. All right. And then also we are hiring. We have a number of positions that we are looking to fill, many postdoctoral positions, as well as staff member positions. So, if you're wanting to join us, then we would love to have you here as well. Debbie, did you have anything to say about maybe the positions available?
No, only that we're excited to be able to hire. I don't think I have anything specific about them, but we're really excited to be bringing in new people, particularly on our postdoc program, the NESAP program.
Yeah. So if you're interested in joining us, please reach out, apply, ask questions. NERSC is a great place to work at. I get to work with some of the most smartest and amazing people, and everyone is very accepting. Everyone is different in their own unique way, and it's just a welcoming environment where you can prosper. So, all right. Well, that does it for our NUG call. And so we want to wish all of you happy holidays, and we are looking forward to seeing you in 2026 and helping you more accelerate your science work. So thank you, everyone, and I hope you have a wonderful and happy holiday and a good rest of the week.